In this instructional video, we will be going over textbook pages 222 through 224. Number 1, how does a scatter plot show the relationship between paired data? So it can have a positive relationship if both variables increase. It can have a negative association if one variable increases and one decreases. So they have opposite directions. Or we could have no association if there is no consistent pattern. Number 2, Marcy always sleeps fewer than 9 hours each night and has never scored more than 27 points in a basketball game. A scatter plot suggests that the more sleep she gets, the more she scores. What scales for the axes might be best for constructing the scatter plot? So when we're looking at our scatter plot, we see that the more she sleeps, the more she scores. Both have the word more, meaning it is increasing, so we can put that as a positive association. Now, when building the scatter plot, and it's talking about the scales for the axes, that means on our X and Y axis, what should we be counting by? So looking at our values, 9 and 27, both 9 and 27 have values of 3. And so we can count by single digits across the X axis. So we would count 1 hour, 2 hour, 3 hour, 4 hour. And then for the 27 points, the y-axis, we would count by 3 points per in order to count up. So it would go 3, 6, 9, 12, 15, 18, 21, 24, 27. So that way you can skip some values, but still have it look appropriate to match the positive association. For number 3, Kyle says that every scatter plot will have a cluster, gap, and outlier. Is he correct? Explain. No, not every scatter plot is going to have a group, a gap, or an outlier. Those characteristics are different for each scatter plot. Number 4, Phoebe constructs a scatter plot to show the data. What scales could she use for the X and the Y axis? So our X axis is going to be shoe size. With the shoe size being 8 and 7, 6, and 5, we can just count by single values. So starting at 1 and going to about 10. For the y-axis, we're looking at the height. We have larger numbers, 60, 64, 63, 60, 54, 59, and 60. So what we would want is we would want to skip the smaller numbers and then we would jump straight to about 55 or so, maybe a little less because we do have that one at 54, so you could start at 50. And then you could count by single digits. Or doubles. Number 5, Jermaine constructs a scatter plot to show how many people visit different theme parks in a month. Why might clusters and outliers be present? So if we're talking about theme parks, clusters and outliers would be present because there are patterns when visiting a theme park. even though a lot of people don't come to the theme park in the month of November, because that would be month 11, you could be thinking about why would that one be lower and that one be higher. Well, Christmas is going to be higher because people have a longer holiday break, versus in November when it's cold, people don't want to be going to the theme park. Number 6, the table shows the racing times in minutes for the first 2 laps in a race. Complete the scatter plot. So we want to compare our 2 values. Lap 1 is going to be going across the bottom for our X values. Lap 2 is going to be going up the Y axis. So for lap 1, it's at 2.4 and then 2.3. We have a lap time of 1.4 and 1.6. 1.6 and 1.3. 2.4 and 2.7. 2.5 and 2.6. 1.8 and 1.6, and then 2.2 and 1.5, which is the blue dot. Number 7, the scatter plot represents the prices and number of books sold in a bookstore. Identify the cluster in the scatter plot and explain what it means. So our cluster is going to be our group of points that would be located about here. And so we are saying that between 20 and 25 for $20 and $25 is when the majority of the books are sold, about 15. How does the scatter plot show the relationship between the data points? We do have 2 outliers to consider, but we can look and see that even though it is slight, the graph is going in a slightly upward direction. Meaning the higher the price of the books, the more books are sold. Which again makes sense, because if you're buying lots of books, obviously your price is going to be higher. Number 8, the table shows the monthly attendance in thousands at museums in one country over a 12-month period. Complete the scatter plot to represent the data. So we're going to graph each point. So 5 and 6. 5 and 9. 6 and 6. 6 and 12. 6 and 36, 7 and 3, 10 and 21, 10 and 27, 11 and 18, 11 and 24, 12 and 24, 12 and 18, 12 and 3. Identify any outliers in our scatter plot. So we would have an outlier here and an outlier there. So the outliers would be at 6 and 36. We also have the outlier at 12 and 3. What situation might have caused these outliers? So the high outlier at month 6 means that in June we had a lot of people come that may not have otherwise gone. And then in month 12 we had very few people come. So that was probably the actual holiday. So in June, having the summer off may have given them an opportunity to go more often. And then in December, that might have been like Christmas, so that way you had less people going. So sometimes having a holiday off can help you have attendance. Sometimes having a holiday off can lower the attendance. Number 9, the table shows the number of painters and sculptors enrolled in 7 art schools. Jashar makes an incorrect scatter plot to represent the data. What error did Jashar likely make? So the number of painters is 30 and the number of sculptors is 25. So 30 and 25 would be about here. And so, but if we look at where the point is located, he did 25 and 30. So he flipped the X and Y axis. Explain the relationship between the number of painters and sculptors enrolled in the school. So based on his scatter plot, we can see that it is going in an upward trend. If we graph it, that would show a positive association. A positive association meaning the more painters there are, the more sculptors there are. Letter C, Jashar's scatter plot shows 2 possible outliers. Identify them and explain why they are outliers. There aren't really a ton of outliers in this scatter plot. If you wanted to consider one, you could consider that one and that one as being away from the group, but because they are still within the line, they aren't outliers from the pattern. Though we could consider them outliers because they are separate from the group. So our outliers would be the 11 and 6, and then also the 33 and 20 and 45. Number 10, use the scatter plot to answer the 10 and 11. 10 athletes in the Florida Running Club ran 2 races of the same length. The scatter plot shows their times. Select all statements that are true. So 9 of the times for the first race were at least 16 seconds. So if I look at my 16-second mark, that would be here, then I should have 9 of those that were less than that, which is not true. There's only 1 that's less. 8 of the times for the second race were less than 17 seconds. So if I look at my 17-second mark, that would be here. And so if we have 8 of those, 1, 2, 3, 4, 5, 6, 7, 8, there are 8 dots below that line, so that is true. there were 7 athletes who were faster in the second race than the first. So if we look at our individual points, that point would be at 14. 14 is slower than the 15 that would be there. Here we're at 16, which is slower than 16, but again, we want faster there. 16 and 16 would be the same. 17 is faster than 15. 17 is faster than 16. 18 is faster than 16. 19 is faster than 15. 19 is faster than 16. 18 is the same as 18. Here, 17 is slower than 19. So that one is faster, but that's the only one, not 7 athletes who are faster. There were 3 athletes who had the same in both races. So the same would have been the 16-16 dot that we counted here, the 18-18 dot that we counted here, and the 15-15 dot that we counted there in that straight line. So there were 3 that were the same. There were 3 athletes whose time in the 2 races differed by exactly 1 second. So again, we've marked out the ones that are the same, so then we can look and compare the others. Here it's 16 and 15, so that's 1 off, so there's 1. We also have here 17 and 15, that's 2 off, not that one. This one, 17 and 16, is 1 off. 18 and 16 is 2 off, so we're not taking that one. 19 with 15 and 16 are more than that. But this one up here is 17 and 19, which is also more than 1 off. So we're not taking that one either. So there are not 3 athletes, there's only 2 athletes who were off by 1 second. For the last one, what was the greatest difference for a single runner in finishing times in the races? So the greatest difference is going to be our value somewhere on this side where we had the 17-second finish, but the 19-second second finish. So that one would be 17 and 19. This one here is starting at 19 seconds, but then he finished the next one at 15 seconds. So that's a difference of 4. So that one would also work. That's the highest, even though it is a negative difference.